All right, welcome to week 5 in CIT 225. I'm still Brother Stevic. I'm still teaching this class. Tonight we're going to talk about, we only have a very few code examples I'm going to show you tonight, because we covered most of what's in this week's lesson code-wise last week. And this week is just a few very specific things. This week is just right and left joins and accept and intersect operators. So, so let me share my screen out here, and then we're going to be talking about a schema that was submitted today. And we're going to talk about tips and tricks and stuff like that. So let me share my screen. Okay, share my screen. Okay, so okay. So the first thing they want to talk about is this command called union.
Okay.
The union command is just a very cheap way, and when I say cheap, I mean like ridiculous, like Walmart kind of cheap way to join two tables. So here I've got two queries here. I'm gonna comment out the union part here for a second. So I'm gonna do just two queries here. Oh, wait a second. Well, I gotta do this here. Okay. So I'm gonna run these two separate queries. And this one is, I've got select last name, first name from actors. And I've got select first name, last name from customers, right?
Yeah.
One second. Yeah, 1 second.
No, it's okay. Take your time.
Okay, just coordinating rides here. Okay. So so it's first name, last name for actor. So, and you'll see in the first one, 2 rows were returned, right? And I got down here 2 rows. And in the second one, 40 rows were returned. So all the union does, right, is returns one all union does, it takes both result sets and puts them into one table.
Okay.
Now,
Okay.
so
Go
the
ahead.
promise, so like here, I've got select last name, first name from actor, and last name like R, and select last name, first name from customer, last name like R, right? So I can go ahead and start, I can do this. I can change this to A. And if I run it, I still get results. I have A's and I have R's.
Yeah, both A's and R's. Okay.
Right. But I'm going to go back to R's here for a second, okay? Now, there's 2 commands. There's union and there's union all. So when I run union, right, I get 42 rows. When I run union all, I still have 42 rows. No, that's just more. So the difference is, if I do union versus union all, I guess the stuff, if there are any duplicates between the 2 tables, the duplicates will show up. Union just does the initial values. Union all gives me all the duplicates. Okay. But the problem with union is under actor, I've got columns. So if I did this instead, right, and I run this, it's still,
I'll give you an arrow.
oh, hang on a second. I put it in the wrong place.
Because I was like,
Yeah,
okay.
I can go here. There we are. I put it in the actor table. So if I do that, it returns. It's all the union wants to know is that there are 2 columns here and 2 columns here. It doesn't matter what they are.
Okay.
It doesn't care. I can even do this. I'll try. Let me see if I do this. So I do union select. Let me go to the film table here, right? I've got title and description from film,
Description.
where title like R. Okay. If I run this, it still works.
So why do you have the description? And I
Oh,
thought that yeah.
because description is also a keyword.
Oh, okay, but
Yeah.
it's
It,
not. But right now it's displaying the
right.
table description. Uh,
Right. There's a column called description,
it's
but
a
there's also a
column.
keyword called description. So that's why it's blue.
Okay. Okay. So because if it's also a keyword, I mean, how would you
Bec-
know? It depend. I don't know what instances we probably find ourselves working on this. How would we know if it's giving us the right um spirit? Like,
a good rule of
okay,
thumb when designing databases is don't use uh clause words in your table names.
okay,
But in this, like most people instead of description will just do that. But well, that's a keyword too. So they just you have to find different ways to do it,
okay,
right?
all
Um,
right,
but with the problem is it doesn't matter what these two columns are. All it cares about is that there's two columns in select, and it'll do any two columns, and it
okay,
doesn't make a difference, right?
all right.
Okay. Okay, now this is the part where I try to start coding on the fly to make this work. Okay, so we've got a command called accept. Okay, and accept does pretty much what you think it's going to do. Okay, it's show me everything that's in here
Except for the bottom
except
one.
what's here.
Okay,
So if
literally.
right, so if let me so if there were a column in here called let me do this here. Let me do this. Insert into customer values, and we need first name. I need we'll do Denver, we'll do Bob, Denver, and then that should be all I need. Column count as a mentioned value row 1. So let me do this. Create table, send SQL editor, give me an insert statement. Oh, is this not for? Okay, so I'll just do this. So let me just do select. This should have been an incremental. This should be, I shouldn't have to put an ID in there. Oh, maybe I do this. Hang on a second. Let me do this. Hang on one second. Customer columns. Oh, okay. That's the problem. That's the problem. Okay, in customer, I've got to do. So let me do this instead. Let me do this. So let's take these here. Okay. So Eva Ramos. And I'm going to turn to actor instead. Actor. I see TOR. And I'm going to do first name, comma, last name. I was trying to put into customer. Customer requires a lot more information than I was giving it.
Okay,
So,
that's why. And they are all what, is
right.
it not null? So
Yeah.
you
So it's
have
all
to
in.
put
Yeah. Like here, I for actor ID and last update or automatic. I don't have to put those in there. But here,
Mhm.
customer ID is automatic. Store ID is not. First and last name, email. These are not. So I had to put those in there. So I just
Uh,
added Eva Ramos. So now in here I've got Eva Ramos, and in here
mhm.
I've got Eva Ramos, right?
Mm-hmm.
So now if I run this with union, right? I
Yeah.
run this with union
It
and
gives
it
you
shows me
both
there's Eva
Eva
Ramos and or by last name, and there's only one Eva Ramos. If I do union all,
and it shows both.
it shows me both Eva Ramoses.
Yeah, I see.
Now if I do accept
Except reduce it.
here, right,
That's
and I run
close.
this, it shows me everything that's in here except what's in here. So Eva
Okay.
Ramos is gone. Okay.
All right.
Now the fun thing is, except didn't work in MySQL until about 2 years ago.
Oh.
They just
Oh,
added it.
that's nice. It's interesting.
Yeah, intersect doesn't work. Intersect's another command, but that doesn't work yet. That's not in MySQL yet. Intersect and union do the same thing.
And I couldn't find a data type for currencies
Okay,
too.
it's okay. So if we do, is it?
I tried, but I couldn't find a data type. I thought it was supposed to be money or
I thought there was two. Let me see. Let's do here. Let me go to File, New Model. Okay, add diagram. Let me add a table. Okay, let me go ahead and look at my data type. So we're gonna do, that's fine, do ID, int, what's my money?
it's
Decimal,
only
tiny
decimal.
block, monthly payment, charge or something. Oh, maybe it's not so money and currency does not exist in MySQL. I thought it did. So
I thought it did
yeah,
before. So maybe
see,
the new updates,
yeah,
or
so
they
let me
want us
see.
to just use integer. I don't know.
Uh, yeah, so put you down here. So let me do this here. Money, data type, MySQL. Decimal. So according to this, use decimal 15 too. So when you do decimal, 15 is the number in front of the data and in front of the in front of the decimal point, and 2 is
Okay.
after. So if you're
So
going to use a
why?
money type, so decimal 15.2 is what you'd use for money.
Oh, okay.
Since there is no money data type
So
in,
I took out the parentheses in there because I didn't know what to put in there. I tried.
yeah,
I tried.
yeah, decimal 15,
So
that's what it is, yeah. So
okay.
you go here, you go to decimal and do 15 too.
Okay. How about that at the time, dates and time? Those
So date time,
parentheses.
so what you want to do with date time, generally speaking, so just table column 2 here, just do date time. There should be a just do that one.
Okay. Same thing with the time. I don't necessarily have to put anything on the
You shouldn't have to.
parentheses
Let's look real
because
quick. See what they want
I
here.
was looking up a video online. I took out the parent. Someone took out the parentheses. I'm like, okay, as long as I know the format, I don't know if it worked.
I like so I do here. This is a great thing to look like. I constantly I've been doing this 20 plus years, right? I still Google stuff. I still go here and look how stuff works.
Mm.
So here, if I do date time, I can do timestamp, which is like the current time.
Mhm.
So yeah, so you use timestamp, you do that instead. So don't be afraid to Google stuff and look up
Okay.
the answer. MySQL tutorial is probably one of my favorite sites to go to.
Mhm.
You should. It's actually interesting. So while we're talking about this, I interviewed. I have my other job. We have two Microsoft SQL Server positions open, and I interviewed two people today about taking the job. And
Mm.
the one thing both of them did that really I wasn't crazy about was they didn't explain that they didn't understand things and they just kind of made it up as they went along. And that's a problem because I can't trust someone who's making stuff up, right? So, um, so bottom line is never be ashamed that you're looking stuff up online. Find like Stack Overflow is a great website. MySQL Tutorial is a great website. Just
Okay.
find some place you can go to get information to pull stuff up
Oh, okay.
because yeah, it's never an embarrassment to look stuff up. I'm like I said, I've been doing this like 20 plus years and I still look stuff up.
Oh, okay.
So because here we are like here. So this is probably a good one. So here we've got how to use the date time function, right?
Yeah.
So here you can do back into our database here we're messing around with, go here and we can use timestamp.
Okay. Yeah.
This date time should work. Date time.
Yeah. Date time without the I think date rather because daytime is
Yeah, that
it
works. Yeah.
includes the date and the time
Right.
together. So
So what
yeah.
happens is when you
Uh,
write the query to get the stuff out, you can do I think we looked at it last week. So if you write a query that you need to get the date out of, right? And you've got date
mhm,
time as your thing. So
mhm.
here, so what here's got a date? What table's got a date here? Rental. So rental's got date in here, right? Let's see. Yeah, so rental's got rental date and it's date time. So if I go here, this is not for this week. This is what I want. Okay, nope. Where'd my stuff go? Nope. That's not it. That's not it. Yeah. So if I go here and I do select, I do this here. I go customer ID. I get last name, and I do create date from customer.
Mhm.
All right, and I run this. It gives me this ridiculous thing here, right? So if I
Mhm.
go here and just do put that there, right, and I run this, it just gives me the date,
Okay.
and then I can do. I can just do time, right?
And it just gives you the time.
I can also
Date.
just do. I can do this.
Okay.
Okay.
Sorry.
So there's a whole bunch of clauses that let me just pull specific,
Mm-hmm. You see.
yeah. So I can do that. It just gives me the year.
Okay, good. Nice.
Okay.
Okay.
So we've done union all. So now,
We don't accept.
yeah. So this here, if this is the way we want to do this. Select last name as actor, last name as customer, and I'm joining the two using my inner join. Now, the last thing I want to show you and whoever's watching at home, on day after day, we talked about the left and right joins, right? So
Mhm.
so I've got an actor table and I've got a customer table that share a last name column, right? So
Mhm.
if I run this, you'll see that everything matches up, right? I've
Mhm.
got 3 Williams, I got 3 Willises, everything's fine, and I want this to go away in the worst possible way. I have 44 rows returned, okay, where everything matches. So
Okay.
now I'm going to do a left join. And what that means is I've got the actor table is on the left and the customer table is on the right. So in this query, what's going to happen? It's going to give me all the last names from the actor table. And then it's
Mhm.
going to show me where the last names match in the
Oh,
customer table, right?
Okay.
So what's going to happen is you're going to have a lot more results and a lot of nulls in the customer table. So I run this now, and now there are three Ackroyds, but there's
Okay.
nothing in customer. There's three Allens, there's Esther and Bacall, but nothing there, right? So it's
Oh,
returning everything that's here, everything in the action table, but only where
they are similar names.
there are similar names. Okay. So there's a bunch that don't exist in either. So I got 200 rows returned. So if I do a right join like this, if I'm joining actor to customer with a right join, it's going to be the opposite. The nulls are going to be in this table, not
And
this
then
table.
the okay.
So I do that, and now these don't exist in the actor table. The Allens are still there, and these don't exist in the actor table. That one's
Uh,
still there, but these don't exist in the actor table, right? Is null works. Is null does not work. Okay. There's a command, I don't remember where it is right now. I'm not gonna look it up. There's a command that checks to see if something's gonna return as null and puts a value there instead.
hmm,
But anyway, so that's the outer joins. So inner join returns only things that match, right?
okay. Yeah.
Left join returns everything in the left table and only what matches in the right table, like that. And right join only returns everything in the right table, but only things that match in the left table.
Yeah.
Okay. And that's what's on your quiz this week. That's it.
Okay.
Okay.
All right.
So you got any questions on this?
I'm fine. No questions on
Okay.
that.
Then let's go ahead and take a look at your schema. Because I'm very excited to go over this. I think you did a very, very good job on this schema.
Okay, thank you.
Okay. So let's take a look at this. Okay. So we got a couple things here.
Mm-hmm.
You got a doctor's table, right?
Okay.
Has a
Yes.
doc. So rule number one of creating tables. Rule number one is table names are never plural. They're always singular. It's not the doctor's table, it's doctor.
Okay.
Don't ask me why. I don't know why, but that's just a common rule. So it'd be doctor, prescription, patient. And I know that seems like kind of like, trivial to talk about, but in the professional world, they look down on that, right? So in
Okay.
the doctor table, you got, and here's the other thing, you just have ID. You want to call it doctor ID or doc ID or something like that, just so you know when you're writing queries, if you have 5 columns named ID and you got select ID, select ID, select ID, it's better if you have doctor ID, prescription ID, patient ID, right?
Okay.
Okay, so first name, last name, specialization, email. So what I'm going to do right now is I think what I'm going to do to make this a little bit better is I'm going to go ahead and build out a schema while we talk, because that's kind of like how I like to do this. So let me create a model here. Okay, so I got this model here. So I'm going to my ER diagram. Okay, so I've got a table here. And I'm going to get my doctor table. I'm going to call this doctor.
Okay.
And in the doctor table, I've got doc ID.
Okay.
Now, when I do IDs, and we're going to talk about this, so this is going to be the deep dive section of this. I've got a couple choices on what data type to use. I can use int, I can use medium int, I can use small int, and I can use tiny int.
Hmm.
Now you might ask yourself what the difference is.
Yes.
So tiny int is, if memory serves, pull my notepad here. So there's tiny int, there's small int, there's medium int, and there's int, and there should be big int.
Yeah.
There should be
Medium.
big. There should be big int too. So let me go back over here. So I've got, hey Leon, I've got int.
Mm-hmm.
I've got two. I got int, medium. I got big int, medium, real. So I got big int too. Hey Leon, how you doing?
Good. I totally spaced it. 9:30 to me said 9:30, but I forget you're on the East Coast.
Yeah, it's cool.
Welcome, Leon.
Yeah. Hey, how's your computer situation?
Well, it is up and on the PC.
Okay.
So, I mean, technically, I should still be able to do what I need to do, but it's just hard now because I have to work. I prefer my Mac. So,
Yeah, yeah, you're not the only. I did a lot of. I am not a Mac person. I used to be a Mac person, but I'm not a Mac person. And one of the reasons why I'm not a Mac person is they don't roll back rollback changes. Once it's there, it's there.
yeah, they
So
require.
what happened is his computer put the latest Apple patch on to the Sonoma OS, and MySQL doesn't work on Sonoma. So it crashed out. And the only way, and I talked to my son, who's a big Mac guy. I talked to the two Mac guys on staff. And I went to one website and I thought they were being sarcastic. Because it said if you don't have Time Machine, you're never going to do it. And I thought they meant, do you have a time machine to go
Oh,
back in time?
yeah,
I didn't realize Time Machine is a software in Apple to roll back things.
yeah,
So on Windows OS, you just go into install things and you can roll back patches
yeah.
without
yeah.
that problem. With Apple, it's one and done. And the only way for you to fix your Apple at this point in time is to either wait for Oracle to approve the OS or roll back to the original the previous. Not you have to reinstall your system.
Oh
Basically,
no, no,
Yeah,
no.
yeah.
that's
So,
I
but
actually
that
That's bad.
thought
yeah.
about going to buying another computer and not updating it.
Wow. Dang, man, that's crazy.
No, no, no.
Okay,
But
so
mhm.
we had gone through the code for this week. It's real simple. It's just doing I'll show you real quick backup here.
I can go
Um
through and watch the
yeah,
video.
it was just the joins, outer joins, right outer join, inner joins. So right now we're going over the schema that I keep forgetting your first name. I know it's not Elder. Elder created.
Emmanuel. Oh man, I
Emmanuel.
keep forgetting to
Emmanuel.
change that.
Yeah. Emmanuel created. He opted to do the project, and he already submitted his ERD. So I'm going over his ERD, and I'm going to kind of touch on what I talked about with you, Leon, about how the tables work.
Yeah,
So I'm about to go into my sermon on data types. So when you're looking at the int, you've got tiny int, small int, medium int, and big int. I'm not sure medium int. I've never dealt with it before, but that's a MySQL thing. So I'm going to leave this out for right now.
Yeah.
So
Okay.
tiny int is plus or minus, and I'm not 100% sure on these numbers, but you get the idea. Plus or minus 128. It's negative 128 to positive 128. Okay, or it's 2 bits, 8
yeah.
bits, 8.
I understood it to be 2 kilobits of
Yeah,
data.
yeah. So I'm just kind of doing the numbers are going to be off, but you get the point I'm making. Okay. So
Okay.
small int is like negative 25,000 to 25,000, and it's 16 bits. Okay.
Oh.
Int is negative 2 billion. Nah, 2 billion. It's not 2 billion. It's like 20 million.
It's a big number.
Yeah, it's 20 million. It's something 20. And I got a story about this to positive 20 million, and it's 32 bits, right? And you notice it doubles every time.
Mm.
Okay. And then big int is just like, 6 billion to negative 6 billion to positive 6 billion or whatever it is, right? Now,
That's 64-bit.
and it's 64-bit, right? Now, here's the thing. When you are choosing your data types for integers, it's very, very important that you choose wisely for a number of reasons. I worked for a company called Property Insight years ago, and their thing was property insurance, property information. They had property information from all over the country in their databases. And they had one big table that tracked all of the sales that the company did. Because what they would do is they would sell that information. So someone would come in and want to look up a property in Arizona. They charge them for it and they'd find it and they keep track of it because you always had access to it, blah, blah, blah. So when they made the table, they did the ID column with int because at the time they either didn't realize that the instant limit had, and when you think 20 million, you're thinking that's a huge limit, or they didn't plan ahead. Because what happened when I started working there in 2005, their sales table was at 18 million rows and 8
Oh.
integers. So they were 2 million away from running out of space. Okay. So we had to go in and change the table and change int to big int.
Good.
And it's just changing a data type, which on a small table of 200 rows, 1,000 rows isn't a big deal. But when we had to change it, two things happened. We had to touch every row and change it to big int, which what happened behind the scenes is it changed that. So when you create a table, and it's stored on the disk, right? That column has like 32 bits of space that it holds open, right?
Yeah.
So what happened was when we changed the big int, it took every 32 bit of space and turned it into a 64 bit of space across the entire table, right? So I'm just gonna do some ridiculous numbers here.
Doesn't that mess up any queries too? Because
That's what I'm thinking. And the space of the computer too.
Well, the first thing it did is it doubled the size of the table.
Jeez.
Because
it's
you had
applying
one,
to all.
yes. So
rows.
every row in that one column went from 32-bit to 64-bit. So there were 18 million rows that doubled in size.
Double of that.
So whatever that ridiculous number. So all of a sudden, and it took 4.5 days to finish the operation. So that database was down for 4.5 days while this changed. Okay.
Crazy.
Will it affect queries? It should not affect queries as long as that query is not calling that column as an int. So normally your select queries and that wouldn't be using an int term or any kind of cast or convert in that thing. Inserts would break because inserts are calling it int. Any other kind of tables, anything that dealt with an integer, that data type would break. But for the most part, it wouldn't. But because we had to go from here to here, we were down. They were down for 4 days, and there was no fast way to do it. There was no fast way to do it.
They couldn't have backed up the table, built a completely new one, and then just migrated over potentially a smaller amount of data after you've gone through and run your big stuff. You have a freeze.
We had a freeze, and the freeze was, we did it over Thanksgiving weekends. So we shut down on we shut down on Wednesday and came back up on Saturday. And we just said we're down for 4 days.
That was a lot of work to do.
It was a lot of work and a lot of watching, because if it failed halfway through, we were in trouble. Because the problem is when you're doing that much of a change, right? And if you're 17 hours into a change and it fails, it rolls back. And it takes 17 hours to roll. For every minute that it took to get there, it takes that same minute to go back. If it failed 17 hours in, it takes 17 hours to roll back. Right? So it was not a good scene anywhere we're looking. And you know, God was on our side that day. He was smiling on us. It worked. It went just fine. There was no problem, right? But when they designed the table, they were short-sighted. They're like, we're never going to be more than 20 million rows. Right there. And if they did, they're like, well, when we get to war, it's gonna be like 30, 40. It was like 6 years later. They hit 20 million rows. So whenever you're choosing a data type for your table, you got to go, okay, what do I really need here? So let's look at here. So I'm creating a doctor table. And the one thing I said, Leon, is when you're creating tables, the name of the table is always singular. It's never plural. So I've got a doctor ID table. I can use big, I can use tiny int, I can use small int, I can use int or big int. I don't think I'm going to have 20 million doctors at any point in time. I think tiny int is probably too small. I might have more than 128 doctors over the lifetime of my thing. So I'll go ahead and make it a small int because I probably won't have 64,000 doctors at any point in time. Okay. Why do you keep doing that? Okay. My next one's gonna be last name. Then it's gonna be first name. And obviously, so I'm gonna do this one. So when I'm doing my characters, I've got char and I've got varchar. Does anyone know the difference between char and varchar?
Well, if I understand varchar, or char is a specific character limit and variable is expandable.
Right. So yeah. So if I do char 13, I do varchar 13. Okay. And this all, so to keep in mind, this all deals with how it saves on the disk. Right. So Lillian, you're right. So if I say char 13, when that column is created on the disk, it takes up 13 bits.
Okay.
If I use varchar 13, it takes up to 13 bits. So here, if I put in that column, it's going to take up 13 regardless. If I do here, if I do the same thing here, it's only going to take up 2, but it can grow up to 13.
Okay.
Make sense?
Yeah, it does.
Okay. So
Can
basically saying,
does varchar have to be preset, or can you leave it
it has to be preset.
unspecified?
It has to be preset. Now,
Okay.
I'm not sure if this works in MySQL, but you can do varchar max in SQL Server or Oracle and SQL Server, Microsoft SQL Server, and that just lets the biggest thing. And the reason why, and here's a deep dive as to why this is the case. So, okay, so let me bring up MS Paint. We may not get through the whole database design today because I'm going down rabbit holes. So,
It's okay.
okay, so when data is saved to a disk, okay, it's saved in something called pages. And each page is 8K big. Okay. Okay. Come on, work with me here. So information is stored in 8K blocks on the disk. 1, 2, 3, 4, 5, 6, 7, 8. Okay. Now, that means if I take 8K of information, it goes on here, right? If one column takes up over 8K, it goes across multiple pages. So your indexing gets pretty jacked up at that point in time. Okay, because now half your table information, half your column row information is here, the other half is here. Half part is here, part is here, right? So as the data gets written to this, it gets written in order like this, right? Okay, so that's like the first, so this is like the first column, and then here's the next column, and then here's the next column, and here's the next, no, different color, give me this here. And here's the next batch of data. Okay. So now each 8 pages is collected in something called an extent. Now, Emmanuel, I don't know if you've ever done this, but Leon has. Have you ever collected baseball cards or something of that? Have you ever collected something where you have to put it in order for it to make sense, like baseball cards or comic books or anything like that, right?
Oh yeah.
So you've got this collection. I used to collect baseball cards. I used to collect Magic the Gathering cards, and you put them in order, right? And when you buy new stuff, right? So here's table 1, here's table 2, here's table 3, table 4. So if I bought more cards, all of a sudden I'm adding data to table 1, but it's going down in this extent down here. I'm adding more to table 2, and it's down here, right?
Yeah.
So what happens is there's fragmentation, right? So as it gets written, all this stuff gets fragmented around, and it's because of one of a couple things. You're adding more information to a table, or your one row in the table exceeds the 64K limit on a table. And actually, you'll see in Microsoft SQL Server, if you ever use char and these things, if you put too much data in a row, it will throw an error saying you're exceeding the row. What varchar max allows you to do is go past that limit.
Okay.
Because what happens is it doesn't store it in that, it stores it somewhere else. It doesn't store it at the extent, it stores it in a different file somewhere else and puts a pointer in the extent to that blob file elsewhere.
Okay.
That was an incredible deep dive. That was like talking about Colab here. So does everyone follow? Everyone with me on this? Did I lose y'all?
No, I think I understand what you're saying.
Yeah,
because when you're talking about fragmentation, I think of disks, especially Windows. PCs are known for needing to be defragged.
Yeah.
In order to speed up. So when you're using var or character, it's putting it in this one line only. But when you're using the varchar, it's actually just putting a pointer in the first block that points out to something else.
Exactly. And just for because you brought up Windows. So remember that little, when you open the Windows fragmentation disk, you see all the little blocks, all the different colors. And when you do the defrag, it lines it all up.
And that is lines up. Yeah.
Databases are the same way. So this is index fragmentation, which you're looking at here, right? So I can run index defrag, and then all of a sudden I've got, let's see, 1, 2, so I can go here.
Everything's gonna be in the same color.
Yep. So I go here and I add 3 more of these. I got to add. Okay, so I go 3 more of these. I'll go here. 1. So I'll do this, right? And then we'll go here. So I got 1. I took away 3. There's 4, and there's 5, 6, 7. So then I'll go here and add 1, 2, 3, 4, 5, 6, 7. All right. So it will defrag, and then all of a sudden your pages and extents look like this. Okay. So if you're used to the old Windows fragmentation, these that little box and all the disks change, the boxes change color, and when it's uniform, everything's great. Indexes are the same way. Anyway, so back to our regularly scheduled program. So I'm going to go here. I'm going to go ahead and do varchar 20. And I'm going to go here. I'm going to do varchar 20. Same thing. Okay, so first name, last name. Now, let's go here and open a table. Now, you had put a column called specialization in here, right?
Where the specialization of the doctor, like
specialization of the doctor, right? Now, that's spelled horribly wrong, but just go with me here. So now, here's where we get to our first issue of normalization. Rule number 1 of databases is don't trust end users to put anything in right. Odds are they're going to mess it up. Okay. So if you're picturing the front end of this and someone's inserting doctor's information, they're putting the doctor's name in, they're putting the patient in, and then they're typing out the name of the specialization, right? So let's say like there are like 2 ear, nose, and throat doctors, right? So I'll have like, one insert name will be like Bob let's see, last name for, so it'll be Denver, Bob, ear, nose, throat.
ENT. Oh, you say
And then
ENT.
I'll have Hale, Allen, ENT,
Oncologist.
and it depending on who puts the information in, it's what it's going to look like. And all of a sudden, this column here has got different spellings for everything.
Different spellings and different.
Right.
I get it now.
Right.
The
Okay.
best way is just to create a specialization table.
So we create a table called specializations,
Okay.
right? And we call it specialization.
Let's see now.
Specialization. Again, ignore my spelling. I'll have special ID. I'll have special ID. And we'll stick with small int. And then we'll have name or specialization. Right? And now what I do is I get rid of this column here. And I go to my handy dandy thing over here, and I go, I have a one-to-many. So one specialization will have many doctors, but one doctor will only have one specialization. So I go here and I go boom, boom, and I did it backwards.
Yeah.
I go boom, boom. Okay. And now I have a specialization table where someone who has the wisdom to do it types in the specializations properly. And then now it just links over to here.
Okay.
Okay. Also, what this means is this becomes a foreign key constraint. Now, foreign key constraints has special powers. What means is a doctor cannot have a specialization that's not in this table.
Yes.
So if Bob Denver is an oncologist, and that's not here, we can't enter him here until oncologist is here, right? The other thing is I can't delete anything out of this table as long as something exists here.
Okay.
So I can't insert here if it doesn't exist here, and I can't delete from here as long as it exists here.
Yeah.
Right?
Great integrity too. So
let's take this another way. Can one doctor have more than one specialization?
Yes.
they could, yeah.
So here's the thing. So here, this is a one-to-many. One doctor has one specialization. One specialization has many doctors. I can't start putting like specialization 2, 3, 4, 5, because who knows how many it's going to be, right? So instead, I create a many-to-many relationship. And I go down here to my many-to-many, and I do this. And it creates this table for me.
That's a linking table. So meaning doctor has. That was what I was planning on doing on my on the what do you call it? What's the other table? On the appointment table.
Right.
That was what I was planning to do there.
Yep.
I have a question.
Yes, sir.
And this stems back from I think our first meeting. You had talked about you should never create a many to many.
Right. So here's the thing. So let's get rid of this here. So this table, if I try to do these two together, this is many to many between the two of them, right? So if I do this and create this joining table, this has a one-to-many here. This has a one-to-many here. There is no many-to-many.
This is one-to-many.
So
two one-to-many table
right.
equals many-to-many.
So one doctor may have many specializations, and one specialization will have many doctors.
Okay.
But since I've got this middle table here, I'm not joining. It's two one-to-many relationships as opposed to one many-to-many relationship. Does that make sense, Leon?
I think so. So you're saying it's okay to create a many to many. I may have misunderstood your comment about you should never create a many to many table because it creates this table.
You should never create a many to many relationship between two tables. You can create this table here,
one that gets created automatically,
right? Because this has a one to many relationship. This has a one to many relationship.
Okay, I see what you're saying.
Yeah. So this is how you get past the potential for a many to many relationship. Okay. So this is one to many, one to many. Okay. So let's continue on with what you're doing, Emmanuel. So you had a patients table.
Mm-hmm.
Let's create a patient table. And I'm not going to go crazy on this.
It's okay.
Okay. And I'm going to do patient ID. And I'm going to do, we're going to do this. We're going to do this small int again. Okay. And then I'm going to do last name. And then whatever. And you'd flesh these tables out more like for doctor, you have like phone number, email address, blah, 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 right?
Yeah, I put it.
I mean, well, actually, let's just stick over here for a second, right? So, we have a doctor table. So where do the doctors work? So let's give hospital, make a hospital table,
Okay.
right? And then we have hospital ID, and then we have hospital name. Okay. So now let's look at this. Does one doctor work at many hospitals?
They technically could.
Does one hospital have many doctors?
Yes.
Yes.
So now we go our many to many. Okay. So now that we have this here, right? Not only do I know what hospital has which doctor, I also know which hospital supports which specialization.
Okay.
Okay. So I have the doctor and their specialization here, and then I've got the doctor in the hospital here. So I now know every hospital that has an oncology department, every hospital that has pediatrics, every hospital that has cardiology, and how many doctors are there from that hospital.
Okay.
Are you following the path of the data?
Yes, I'm following.
You following, Leon?
Yeah, I understand what you're saying.
Okay, cool. So here I've got my patient table, right? So now I want to know about which patient went to which hospital with which doctor and which specialization, right? So what I'm going to do here is a little different. I'm going to create a table here, but I'm going to do many between patient and hospital, right? But then I'm going to link in doctor. So now I know which patient went to which hospital and what saw which doctor and what that doctor's specialization was. And also here, I'm going to add a column, an additional column to this table of date. So I know when they were there.
Okay.
Okay. Now, I told Emmanuel before that every table must have a primary key. It is a requirement that every table have a primary key. So when we look here at our special table, this column is the primary key because it's the one thing that'll never repeat. Okay. This column, this table here,
the linking table.
These two columns are the primary key.
Okay.
Even though they're
Because
considered foreign keys elsewhere?
yes, because in order for something to be considered a primary key, it can never repeat in that table.
Okay.
So here under specialization, 1 is obstetrics, 2 is gynecology, 3 is OBGYN, 4 is oncology, 5 is nephrology, right? So that ID will never repeat. Here, Bob Denver, William Hale, blah, 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 those will never repeat here. Now, here, Dr. Denver has oncology, those two will never repeat again. So we use these two as the primary key. That way we don't have to add another column here. Okay.
You should never touch this table, if I understand correctly, right?
You can add you can add stuff to this. You can absolutely you could add like graduation date or when they became certified, because remember specializations are certified. So you can add to this column, you can add to this table here, certification date. Cert date. And you can do expiration. of that certification. So you can absolutely add to this table, because I added over here. I created this one where I had hospital to patient, and I added doctor to it, right? So you can absolutely add to these. So the specialization has a date that was certified and a date that's expired. So now I can find out what doctors have expiring certifications in their specialties.
Okay.
Okay.
So
Good.
yeah, so yeah, I totally understand what's going on here because so what happens to the appointments? Like I know this it's for many hospitals and many doctors. All right. I was only thinking about just one hospital.
Yep.
Yeah, I didn't think it through. Like I didn't see the possibility of having it broad like this.
Yep.
But I mean, it's a possibility, and you've made it really clear here.
Yeah.
So the path where I have the appointments,
Mm-hmm.
and because on the path where I have the appointments, I have, the
Wait,
status and
let me finish my thought process here. So we'll get to
okay,
that.
okay.
It's 10:33 right now, so I
Oh,
don't have much
okay.
more time to go. So we can pick this later, but I want to finish the thought process here. So here on this table here, doc ID and specialization ID can be my primary key.
Okay.
Okay, because these will never repeat again.
All right.
Because Dr. Denver will only ever be oncology once, and the certificate, so these will be the same. Now over here, right now I've got patient ID and hospital ID as my primary key. Is it possible that these two would repeat?
No.
Absolutely. If that patient went back to the same hospital, it would happen again.
Okay.
So that can't be the primary key. Could I go here and add doctor ID to that primary key? Is it possible that the same patient would go to the same hospital and see the same doctor?
Yes, it's possible.
Absolutely, that would happen. So what I need to do is none of these can be the primary key. So in this case, I would actually have to make a primary key. Because that's the only thing that won't repeat.
Okay.
So a patient has hospital ID. The patient could technically go to multiple hospitals.
Correct.
So would that ID be different then? Or I guess I
Yeah.
don't.
So let's see. So let's go
So
here
there's
again.
hospital A, B, and C.
Right. So I've got a
Uh,
patient. I've got Dr. Denver and Dr. Hale. I don't know. I've got Gilligan's Island on my mind, but I got Gilligan's Island on my mind. And I've got hospital A, and I've got hospital B, and I've got hospital C. Right. And I've got patient Wilma. I got patient Betty, and I got patient Fred. Okay. So Fred went to hospital B and saw Dr. Hale. Okay. On 2/5/2025. Okay. But then Fred went back on March 25th. And then Fred went back again, but this time he saw Denver, and he saw Denver on 3/30. And then Fred went back to hospital C and saw Denver on April 30th. Okay. So now, if these two columns were primary key, it's repeated twice or three times. So I couldn't do just patient ID and hospital ID as the primary key.
Okay.
If I did patient ID, hospital, and doctor ID, these repeated, so that can't be it either. So the primary key has to be a column that is never repeated through the entirety of the table. And combination of doctor, hospital, and patient happen all over the place.
think your audio is breaking.
Yeah, you're cutting out real bad.
Oh, I think my battery's dying. Okay. You still can you hear me now?
Yeah,
Yeah.
I can.
Yeah, my battery's dying. Okay. So we want, whenever we create a table, we got to make sure that there's a column in there that will never be repeated. And in this case, in here, these two here will never be repeated. In here, these two here will never be repeated because Dr. Hale is at Hospital B, and I'm not going to put another entry in that table for Dr. Hale Hospital B. But here, Wilma can go to any hospital and see Dr. Hale or something like that. So this combination, like I showed you here, this combination of doctor, patient, and hospital can repeat.
Okay.
Okay.
So the patient has hospital ID. That would be, if I were looking at your example, there would be 1, 2, 3, and 4.
Yep. So I go here, and this would be 1. This would be 2. This would be 3. And that would be 4.
And would that get populated automatically?
Yeah.
Or do I have to think about that?
No, you'd have a in Microsoft SQL Server, it's called identity. In this, it's called increment. You create the table, you're going to set it for increment, and it'll just automatically increment the table.
Oh yeah, that's the AI auto increment.
Yeah, it'll auto increment. Yep, that's it here. So I do that. I check that box there.
Yeah.
Okay.
It's not letting me check it, but yeah. Okay, so that's what that is, right? Okay. Now I'm gonna. So now,
You're
so
fine.
okay, so now I have the patient was at the hospital, saw the doctor, and on that date, but I don't know what happened at the hospital, the patient. So I'm gonna make a table called, what did you have here? Let's see what you had. You had medical records. So here's a funny thing. The second I saw this table in your database, I immediately said, this is a HIPAA violation and this can't be here.
Okay.
I don't know. Are you in the States, Emmanuel?
Yeah.
Okay. So yeah, so HIPAA violation, like this actually, the way this is set up is a HIPAA violation. So, but don't worry about it. It's fine. They're not going to come after you.
Okay.
It's the funny thing. HIPAA laws are why doctors are the only profession left on the planet that are required to use fax machines.
Wow.
You cannot email medical records.
Jeez.
Oh yeah. Okay,
That's so far
so
from where I'm from.
yep. So here, so let's see. We don't know what happened to the patient here, so we want to do treatments. Procedure, right? What procedure was done to them? So procedure ID, procedure name, right? And then we go ahead and do this, and we do that, and boom, boom. And on the procedure, we can do costs. And then we can go ahead. You had on yours, you had let's see, you had prescriptions and all this other stuff. So this kind of gives you so this kind of gives you the idea of like, and the reason why I like doing it this way, you kind of watch the flow of how the the tables are kind of created, right? I started with doctor and I had one table and I ended up with 3, 4, 5, 6, 7, 8. And if I kept going in an hour, I'd probably have 30 tables.
Yeah, of course.
Right. And this is why I say stop between 8 and 10 tables. Because to me, 10 is the magic number that if you pass 10, you're not stopping till you get like 30 plus tables.
Yeah.
So now in the case of what let me see if we can do. So now, Leon, when I was looking at your, the table of layouts that you said, I was talking about a one-to-many relationship because you had, what was it? You had like, it'd be like if a doctor only had one specialization, right? I would
Mhm.
get rid of these. And then I would just do this.
Okay.
The specialization would be here and it would just link directly to doctor.
Now, you were talking about equipment, adding
Yeah, so
equipment.
equipment. So yeah, with your table, so let's like over here real quick, right? So you have an equipment table, right? And thanks for reminding me. Equipment table, and you have equipment ID and you have name, right? And then you have equipment type. And then you have equipment type ID and then name, right? And then, so here's the equipment that you have, and here's the type of, if it's a bike or a bike seat or a basket or a tire or something like that, right? And then you just link them that way. So, and then you, to your point, you said you could, and the reason why you do it this way is you could expand more than outside of just bikes.
Yeah.
Yeah. So, and then when you're designing databases, you always, so like Emmanuel, you said you didn't picture doing this for more than one hospital, right?
Yeah, I
But
just
when you're, yeah, so when you're designing databases, um, you know, when you're designing databases, you want to design in such a way that there's always room for growth, right? So it's easy to add things on. So let me bring up one type here and then I'm going to call it a night, right? So what I've seen some people do is I've got my equipment table, right? And so then what they'll do is they'll make a bike table as a piece of equipment, right? And then they'll do a table and call it wheels, wheel table. Or they'll
Yeah,
do a table called,
that'd be way too
so
many tables.
right. And so what happens is the problem is, or on the equipment, they'll here they'll go come here. They'll create a bike column. Or they'll create a wheel column. Right? They'll do this as opposed to just having the equipment type table, right? And the reason why I'm bringing this, I don't normally bring this up now, but I'm going to bring it up now to see who's listening. When you're planning a database, when the database expands, you want to have to add data to a table, not change the schema, right?
mm,
So, for example, in this case, I need to buy a new headset for this computer. So here, if I do it this way, where I've got different columns, right? And let's say I've got this business been running for 6 months, and I added a new piece of equipment. I added scooters, right? I now have to go and change the schema of this table to add scooters, and then I've got to make sure that the not null is there. Any query I have that specifically called those columns out, I'm changing a lot of things downstream because I changed the schema of this table. If I'm doing it where I've got a different table for each item, then I've got to create another table called scooter and then link it in here and do all the changes, as opposed to just going in here and adding another row. Because this is linked. I linked it backwards. Right? So we don't want to change the schema to change when we add things. We want to just have to add a column or add a row of data, right? So in your case, in this one here, Emmanuel, geez.
Yeah, we get what you're saying.
Yeah, in your case here, you have like, East Hospital, West Hospital, you have different tables for different hospitals, as opposed to just adding a hospital here. All right. Where are we at time? And I got a early day. Seminary starts really early here and it's almost 11 o'clock. So
mhm.
But do you guys understand what I'm talking about here with the database design, how this works?
Yeah, I
Yeah.
think I understand.
Yeah. So thanks for Manuel for letting me share this.
It's okay. You're
But
welcome.
this is, so here's a good, and here's the thing, if you just take this and add a couple things to it and go with it, I'm totally cool with that, right? But this gives you an idea on how to get those many-to relationships into one-to-many relationships, how to normalize your schema so that
Mhm.
you're not, having tables that are unnecessary. So
Okay.
with that, I'm going to call it a night.
All right.
And then we'll reconvene next week and we'll talk more about this stuff. Next week, there's a lot of code to talk about, though. Next week, there's probably 35, 40 minutes of code to talk about.
Okay. To generate, just before you leave, to generate the code for this
Database,
ERB here, database,
board
it's
engineer.
forward reversing, right?
No,
For,
reverse takes the
sorry,
database,
for
this.
okay.
So database,
So
board
it's forward
engineer.
engineering.
Yep. Next.
Okay. I just want to be very sure.
There it is right
And
there.
then I
There it is.
copy this.
Yep.
Do I need to click next here or just
Nope.
close it?
You just copy the clipboard or save it to
Okay.
file,
All right.
whichever it
Okay.
is.
Okay.
But this is, so I wouldn't do this until you're absolutely done with this, because
Done with it
between
with
now
the
and week 13, your schema is going to change a lot.
okay. Okay.
All right.
All right.
Excellent.
Thank-
Leon,
thank you.
I'm glad you're back on the saddle with the database. I'm sorry it's on a PC, but that's the world I live in. So
Yeah.
it's yeah. All right, guys. Have a great night. I'll
Yeah.
talk to you guys next
You
week.
too. All right.
Bye.
Bye-bye.
Bye.